All right, guys. So I have sent out a handout entitled Math 160 Review Chapter 4 to Chapter 7. I'm going to do a little video with the solutions to this. This is what used to be Test 2, so I renamed it Practice Test 2. I will identify the parts, the problems here that will apply to the next quiz, and the rest of it will apply to the quiz after that. Okay, so the very first one is not gonna be on this next quiz, but we're still gonna do it because it's gonna be on the quiz after that. So number one has this distribution here. Let me pause. Okay, so I got that written down. I've added a couple of columns that they're the blank columns that are on the page. You just have to remember what they should be. They should be x p of x, so I can figure out the mean eventually, and an x squared p of x, so I can figure out the standard deviation eventually. To show that it's a valid probability distribution, you just have to check, do all of these add up to be 1? And they do. 309. Yes. So the sum of the probabilities is 1. Check. And then each probability has to be between 0 and 1, which they all are. Each probability does. The x values can be whatever they want to be, whatever they happen to be. Okay. So that's what it means to show that it's a valid probability distribution. Part B says find the mean and standard deviation. Okay, so for that we could do, let's do this on the calculator. Be a little bit easier. I've got that pre-done. Let me see if I can make this show up. You guys can see that. So now I want to do L1 times L2. That's my x times p of x. And then L1 times L3. That'll end up being x squared p of x. So let me let you guys see those. That's what you would write down in these next two columns. What I really need to get right now is the sum of those. So let me show you a little shortcut. See if you guys can handle this. You could either go ahead and do second list math sum. Let's just do it this way. L3, because then it's not too long, because you could just do that. L4. So I've got my sum of my L3. So the sum of xp of x, which is the mean, is 4.453. And the standard deviation is going to be, dependent on this guy in part, 39.539. That's the sum of x squared p of x is 39.539. So that's going to be the square root of that minus the mean squared. So if I do that, it'll be the square root of what I just got minus 4.453 squared. Bam. So I get 4.44. 4.440. I like it. Boom, it disappeared. Huh? I had to pause for a second. Let me see. So that's part A. Part B. Now, it's a little bit of magic. All right. Magic accomplished. It's really wobbly. Sorry about that. Anyway, so part C says, what's the probability x greater than 2? Well, the only thing that x greater than 2 leaves out is this one. So I could add these up, or I could just do 1 minus 0.251 and get 0.749. If you add these up, you'll get the same thing. That's math. Part D says, this should sound very familiar. What percent is within 1 standard deviation of the mean? So here's the mean. If I go up 1 standard deviation, I end up at what is going to be 8.893. If I go down 1 standard deviation, I end up at 0.013. So what's in there is going to be 3, 6, and that's it. 3 and 6. If you add 3 and 6 together, I get if I could just read my own writing, it'd be amazing. I get 0.506. I believe. Yes. So just over 50% for part D is within 1 standard deviation of the mean. I like it. Okay, so again, you can pause it there. You can do whatever you like. It's about to go away. Poof. All right. Looking at part 2. Part 2 is just going to be using the z-score chart appropriately. So the probability that z is less than, so it's to the left of negative 0.52. So to the left of negative 0.52, I want this area here. That's exactly what the chart's going to tell me. Negative 0.52, I get 0.3015, 0.3015, and that's it. Done. 0.3015. Kick butt. So that's part A. Part B says to the right of negative 3.16. So I want this much. So if I look up negative 3.16, I'm going to get what's below it. So if I look at negative 3.16, I get 0.0008. 0008. So that's what's going to be here. So over here is going to be 1 minus that 9992. Yeah, so it makes sense. Almost the whole thing is above that way low z-score. Part C is going to be that one where we have to look up 2 z-scores. I want 0.14 and 1.98. I want the area between those. And if I look up 1.98, let's do that one first. 1.98, that's going to be 1.98, 9761. So 97.61% is below 1.98 standard deviations above the mean. That kind of makes sense. It's a huge chunk below it, and that's just too much for the answer, though. The answer I just want between there, so I've got to subtract off whatever this area here is. If I look up 0.14, I get 0.5557. 0.5555. Okay, stop. So to get the area between those two z-scores, I just have to subtract those two. Let's see what I get. 4204. Sure, I'm going to stick with it. 4204. Yes, I like it. Kick butt. All right, I'm going to pause. You guys can pause if you want to yourselves. Then we get to number 3. Let me move this over here. Everybody. All right. There's got to be a better way to do this. I unpaused it too soon. All right, let's see if I can handle that. That's not too bad. Number 3 says, find the z-score that has an area of 91% below. So another way for me to ask that question is, find a 91st percentile z-score, because that's what a percentile means. So I want to find a z-score that's got 91% below it in a standard normal. So I know that is not a z-score, 0.91. That's why I put it up there. It's an area, and areas are in here. To have 91% below it, it's got to be above the average. So I know it's going to be a positive z-score. You have all these things. There aren't all these things you have to memorize or bullshit. It's all these parts that are working together to help you get the answer. So if I can find the closest to 0.91, so if I look in here, 95, 97, 92, here we go. 9 ones are in here. It looks like the closest is going to be 9099. So let's see, what z-score is that? 1.34. 1.34. Done. That's part A. First part. Didn't have a part A, but oh well. The second part says find the z-scores bounding the middle 91%. Now this is going to be a little bit different. And I want you to realize something. This is why you draw the picture. I could tell right now that this is nothing that my z-score chart can handle. It cannot handle this shit. Because the z-score can only handle areas that are below a z-score. The z-score chart can only handle areas that are below a z-score I want. Now I want this z-score and I want this z-score. What area is below this one? Think about it. 91% in here, 9% outside, which means 4.5% on one side. 4.5% there. So now I know this z-score that's bounding the middle 91 along with this one has 4.5% below it. It has to. So I can look up 0.045 because the chart understands areas below a z-score. Now I've got the area below the z-score. I know it's a negative one. It's got to be below the mean. So if I look at 0.045, the closest I can get to 0.45, here's my 0.4s. 0.45. Looks like there's a 4.55, but there's a 4.46. That's closer. Negative 1.70. Negative 1.70. So I don't even have to look up the other one. I know it's going to be positive 1.70 because of symmetry. Kabam. That one's done. Yes. All right, moving on to number 4, and then I think I'm going to, I'm at 11 minutes. Okay, I'll do one more on here, and then I'm going to slice it up a bit. Number 4, let's see. So it tells me the mean is 281.2. Standard deviation is 34.48. And the first part asks me if we pick one student, find the probability X is bigger than 302. All right, so I can draw that, no problem. I've got the mean of 281.2. 302 is up here somewhere, and I want greater than that. So I make a z-score. And let's see, standard is 34.48. Let's see what I get. Where's my, there you are, come here. 302 minus 281.2 divided by, what was it again? 34.48, bam, 0.60. So of course, if I look that up, I'm not gonna get the answer. I'm gonna get the opposite I want, 0.60. So for 0.60, I get 7257. So if I do 1 minus that, I get the answer, 2743. Chapow! All right. Let's see. Actually, I think I'm going to stop that one there. So this first part went up to 4A, 1. Yeah, very specific. All right. So the next part, I'll start at 4A, 2. Okay.